Hi guys, welcome back. Let's look into the review for the electrochemistry quiz. These questions have a different pattern than the ones that we solved in class. Let's look into it, and I'll also explain any concept that needs to be revised further. Okay. Question number 1. They are giving you an electrochemical cell. So normally we know from our class generally what we do for electrochemical cell. So we always have our anode double bar cathode. We have seen this in class. Okay, so now this is my anode, this is my cathode for the electrochemical cell. I think something is missing here, sorry guys. This has to be double bar and then copper 2 plus going to copper solid. Obviously there is a reactant missing here. Which of the statement is true? So now they are talking about what's happening. So we know from our class, this is the way we write. This is going to be a reactant anode, single bar reactant cathode, double bar, product anode, single bar, product cathode. This is what we are going to write. And our cell reaction is always reactant anode plus reactant cathode, giving you product anode plus product cathode. So I am going to be using up my H2, goes down, my copper 2 plus goes down, my H plus goes up, and my Cu, we cannot say concentration, but the amount of copper solid, this is solid, it goes up. So we can say that H plus ions are formed at anode, which is true, and copper 2 plus is produced at cathode, which is true. So this is alpha. Simple and straightforward. Going to question number 2. Zinc gives H2 gas with H2SO4 and HCl, but not with HNO3. Now, we saw a different pattern when we are using KMnO4. We cannot use we cannot use HCl, but we can use H2SO4 and HNO3 because these are already oxidized form. We cannot use the same logic here because the different set is given. So it must be some other reason. So here we will see this not as E-chem but as a direct reaction in our P block later, where my zinc reacts with concentrated HNO3 and dilute HNO3. But at this point, we should know other options. Zinc acts as an oxidizing agent, which is wrong. Zinc acts as an oxidizing agent, it gets reduced. Zinc 2 plus can get reduced. Zinc we don't reduce. HNO3 is weaker acid than these two. That is also wrong. In electrochemical series, zinc is above hydrogen. No, that is also wrong. The way we write it, zinc is below hydrogen. NO3 is reduced in preference to hydronium. This is correct. So if NO3 is reduced preference to hydronium, then NO3 would not be used in such a case. Number 3. Consider the following 4 electrodes. So they have given you these electrodes, but one thing we want to say is all of these are on the same side, same setup. So really the reaction is copper 2 plus going to copper. So now we can write down our Nernst equation. Nernst equation is E cell equals E naught cell minus 0.0591 by En log of Q. Q is nothing but product over reactant. This is not log of K like books give you, it is log of Q already. Always log of K is only when E cell is 0. So now this tells you E cell is proportional to. So now you have a negative log product over reactants, or E cell is proportional to log of reactant over product, or proportional to reactant over product. This is a shortcut way of doing it. So my reactant has to be very high, product has to be low. So where do we have this? This one. So my Q is better than my R, better than my S, better than my P. So it is delta. Going to question number 4. So they have given you a cell and then they have given you EMF of the cell. If you add KCl such that the final concentration is so much, what will be the KSP? Now what we want to do is, if you write the, maybe I'll get some white get some more white space to work at it. Okay, if you write the cell here, you're going to have E cell equals E naught cell minus 0.06 roughly divided by n. N value can be taken as 1 or 2 here. Remember, I told you in class, however you want. So if you want to take it as 2 log of, that's my reactant product. So product over reactants. So I have my H plus right here. We know that it is squared times my other product is Ag solid. I don't write it down. Reactant is H2 pressure times concentration of Ag plus. Got it? Now we will have 2H plus and 2 AgNO3. So we have to have a squared here. Okay. Now if you look at it, everything is given as 1. This is 1, this is 1, this is 1. That tells you that all this will cancel out because log of 1 is 0. So E cell equals E naught cell. So this essentially is also your E naught cell. Now we have our second electrode or second setup rather. We are going to write the same thing again. In this case, the E cell is 0.222 equals your E naught is 0.7995 minus 0.06 by 2 log of. I have not changed anything in terms of the anode. So this is 1. Now Ag plus is not 1 molar anymore because Ag plus, when you add Cl minus, they react with each other. So I will have Ag plus Cl minus giving you AgCl, which gives you Ag plus and Cl minus as a KSP setup. So this will completely combine, but it won't completely dissociate. This is going to be sparingly soluble, so very less. How much? I don't know. So I'm going to calculate it. Ag plus squared. So now we know everything. Can you calculate Ag plus? Ag plus calculated. So I have this. Now what is our KSP? KSP is Ag plus times Cl minus. Now Cl minus is 1 molar. Ag plus you calculated. Plug it here and then calculate here KSP. Alright. So you should get something like alpha. KSP setups are extremely important in your NEET and JEE mains. Question number 5. Question number 5 is very simple actually. For the cell, if the cell is to exhibit, so let's write the cell. E cell equals E naught cell. So I have set it up right here, but you have to watch out that as you write the cell, what is given is the opposite of that. So we will take care of it later. Now, if the cell is to exhibit E cell equals 0, so what if this is 0? So if this is 0, E naught cell equals, this goes to the other side, changes in sign, so I have this. Now they are telling you what it should be. So this is actually E naught. So I plug in my E naught, I calculate what, you take it to the other side, what this is going to be. So if this is going to be 0.33, then the value of this is going to be 10 to the power SN2 plus by PB2 plus equals 10 to the power 0.33 or anti-log of 0.3. And remember, when I go from here to here, I used this, flip this over. Understand, you have to flip it over because what is given is not what is given here. Okay, all right. Next one is a variation of what we saw in class. When we have a cell like this, for example, if this is HCl, then everything else will cancel out. But this is not HCl, this is weak acid. Weak acid 0.1 molar. If acetic acid is 0.1 molar, H plus equals, we know this, square root of, remember we used to do this before, even if you want it, I'll set it up. This equals, when we set up a ice table, we have C x times Cx divided by C into 1 minus x. C will cancel out, and also 1 minus x is approximately 1. So we saw Ka equals C x squared, or x, which is here H plus, this equals here This is from ionic equilibria. We have seen this many times. X equals H plus equals square root of Ka by C. So now my H plus is not equal to my C, it is a function of Ka. So obviously it is going to be less. If this is less, then they won't cancel out, so the EMF will not be 0. So because they have different H plus, can I say it has different pH? That's the reason. Okay. Now going on to the next one, current flows through. So I have been given my I, I have been given my T through X. The result of decomposition is 0.2 mole. So I have told you this, moles electron equals IT over F. So you can calculate moles electron. Moles electron, if I know, oxidation number is nothing but moles electron by moles of metal. Actually this is not a formula, it's very simple. If suppose it is Ag plus going to Ag, I need 1 mole electron. So 1 mole electron will use up 1 mole of Ag plus. Okay, so if I know moles electron, I should know the moles of Ag plus. But if it is copper 2 plus, this is 2 electron process. So moles electron is not equal to moles of copper, it is actually more. So this is how you calculate the oxidation state. It's very simple. So all you have to do is get a ratio. Moles electron is always greater than or equal to moles metal, because a metal needs at least 1 electron to get reduced. So either it is equal or more than 1 electron to get reduced. Straightforward. This is also straightforward. We know that I told you how to remember the Echem table, and also told you the ones you have to remember for NEET. So we know my silver is above my cobalt. So if I am forming a cell, I also told you when you form a cell, unless the examiner tells you, it is always a galvanic cell. So galvanic cell highest voltage means silver has to get reduced, cobalt has to get oxidized. So we are basically going to have this cell. Obviously aqueous here, Ag plus Ag. So we want our reactants to be high in concentration. This is a solid, I don't care. I want my silver to be high and the product cobalt to be low. So I want my silver to be high, cobalt to be low. I should get an option of delta. Going to question number 9. So we are given certain values and then a cell equation. I have, for simplicity's sake, I have actually set it up right here. So now when you see here E0 cell corresponding values, I have set it up. If you calculate the E0 cell, you are going to get a negative value. If it is a negative value, means it is a non-spontaneous reaction or the backward reaction is spontaneous. It's a straightforward one. Just setting up value. The only thing that you have to watch out is Hg is not going to Hg2 plus. Hg is going to Hg2 2 plus, or it's an equivalent of Hg plus. It's a 1 electron process. This is also a 1 electron process. Just for simplicity, instead of putting half here, I put 1 and put 2 here. And then we saw in the class that that is not going to matter because the 2 will cancel out if you want. However you set it up, no issues. Watch out for the powers. That's the only trick in this question. Okay, moving on, 10th is from the last part of electrochemistry, electrolytic conductance. So you are given concentration, resistance, cell constant. Cell constant we can use a symbol G star, then molar conductances. So we know our setup from before. Conductance, or let me start from beginning. Resistance is proportional to, so resistance increases with length, decreases with area, or resistance equals rho L by A. So if we do conductance, then we can do conductance C equals 1 by R. So it is 1 by rho A by L or kappa A by L. So here they are giving you concentration as a resistance, so they are giving you resistance, so we can use this as 1 by R if you want. You can calculate kappa, correct, because cell constant is given L by A. Now when you see, I can actually go into directly calculating my molar conductance. Molar conductance is nothing but 1000 kappa by C. We saw this in class. If C is in molar, this is moles per decimeter cube. To account for the decimeter cube, centimeter cube unit problem, we have this 1000. Otherwise, this is a straightforward formula based question. This is also, these two are extremely simple, straight from class. Limiting equivalent conductivity of these are given. So I told you the way you want to read, ignore the numbers. Cl is present, it will cancel out. K is present, it will cancel out. When you add it, you are going to have equivalent conductance of NaBr, which is also equal to equivalent conductance of the corresponding ions Na plus plus Br minus. I am giving you Br minus, I am asking you what is Na. It's a straightforward equation. So it is 50. This is even more simpler. Here if you see the ionic conductivity of barium chloride, barium is given, chlorine is given, all you have to do is calculate that for barium chloride. Now we told that when we have molar, you have to multiply by the corresponding coefficient, because when I put barium chloride in water, I get 2 times the amount of chlorine. Each chlorine is 76, means twice the amount it is going to carry the charge, so I have to account for it, you have to multiply. This is again straightforward from class. Okay, 13th is a little bit different than the other ones that we just saw. Electric current is passed through this. So I have told you this before. When you do electrolysis of water, each mole of hydrogen is equal to 2 moles electron. Each mole of oxygen liberated is 4 moles electron. So now I know my 112 mils of hydrogen equals, you can set up however you are comfortable with. We can do 11.2 times 10 mils or 11.2 times 10 times 10 to the power minus 3 liters. Correct? Milliliters to liters. 11.2 is half a mole. Correct? This is 22.4 is 1 mole, 11.2 is half a mole, half times 10 is 5. So this is 5 corresponds to 5 millimoles. Now 5 millimoles, I know that hydrogen corresponds to twice the amount of electrons. So 5 millimoles is 10 millimoles electron. I know millimoles electron, moles electron equals, which I just calculated. We can say 10 times 10 power minus 3 equals IT over F. You can calculate your I. Should come to 1. Fourteenth is rather straightforward. Faraday's second law we saw in class. On passing current through 2 cells connected, they are connected in series, meaning you can use Faraday's second law. So basically, I have a cell, I am connecting them in series, not in parallel. So the same amount of current is going to be passed through them. They are going to have different amount of metal deposited, because the metals have different molecular weight and equivalent weight. So now we can say weight. We saw this, WA by WB equals equivalent weight of A divided by equivalent weight of B. And I also told you the pattern, 3 things will be given. One is asked for. This is a straightforward pattern. It's better to set it up this way, so you know the numbers cancel out. 15th one, just like the previous one. I is, not this one, the previous page we saw. I is given, T is given through a molten metal deposits, so weight is given, oxidation status. So same like oxidation state before, I told you that oxidation state can be written as moles electron by moles of metal deposited. Now I know the mass of metal divided by atomic weight will give you moles of metal. Moles of electron is IT over F. You can combine them into equation if you want, like this, from our Faraday's first law, and calculate it. And also atomic oxidation state can be given this way, or it is also atomic weight by equivalent weight. Now where do we get this? Oxidation state is nothing but your n factor here. Number of electrons in oxidation state, so it is equal to n factor. So n factor is molecular weight or atomic weight, molecular weight if it's a compound, atomic weight if it's an element, divided by equivalent weight. It's just the same concept asked in different ways. 16th is very simple if you just get the equation right. Nitroarene, so this could be nitrobenzene or any arene, doesn't matter, only this will get reduced. So if you can balance it, it will be a 6 electron process. The other way of knowing that is, a nitroarene, nitrogen is attached to a carbon, attached to oxygen. So oxygen is minus 2, this is minus 2, carbon compared to nitrogen will be plus 1. So if you look at it, this is more electronegative, but oxygen wins over nitrogen because this is more electronegative. So minus 2 is minus 4, plus 1 is minus 3, accounted by nitrogen as plus 3. Same way, if you go here, nitrogen is attached to hydrogen, carbon, plus 1 because all of them are lower in electronegativity than nitrogen. So nitrogen is minus 3. Plus 3 going to minus 3 is 6 electron process. Then the rest is simple. Sorry, this is 25 right here. Electrolysis of NaCl solution is given. Now in class I told you electrolysis, these are the two possibilities. These are getting reduced, so these are your OAs, these are your RAs. Also in class we saw this is our SOA, WOA, this is our SRA, WRA. This is supposed to be the one happening, but I told you why, what happens. This is because of over potential of water is the reason why Cl gets liberated. Now when you see here, this has a lower potential, so this is going to be favorable. In essence, basically you have your H2 getting liberated at the cathode, Cl2 getting liberated at the anode. And also I told you, remember this, POH or pH keeps increasing. So now based on what is given, I have 600 centimeter cube. 600 centimeter cube. If you want, we can do this. 1 decimeter cube is 1000 centimeter cube. Okay, so that is basically 0.6. This is 0.6. So I have given molarity and volume. So this is 0.6 liters. So I can calculate my moles if I want. It should come to, sorry, I'm missing a 0 here, 0.6 moles OH minus. Now we know the data. Let me clear it now. Now when you look carefully, what they have given you is, they told you during the same period so much of copper was deposited. So this is the amount of copper deposited, 31.80 or 31.75 approximated in the question. So many grams of copper, molecular mass of or atomic mass of copper is this, so divided by n factor is 2 electrons, 2 will give you moles of copper. Because copper needs 2 electron for every mole of copper to be deposited, the moles electron is times 2, 1 mole electron. Now you can see here 2 mole electron is 2 OH minus, then 1 mole electron is corresponding to 1 OH minus. So this is the moles of OH minus expected. But what is the moles of OH minus formed? So this is the moles of OH minus formed, 0.6. So what is the efficiency or the yield? Sorry, we don't even need to do this. This is based on calculating the mass. I can just do 0.6 by 1 times 100 is 60. Okay, so that's going to be Charlie. 18th one. So I have my current and time. So I am passing this through a 1 liter solution. This is conveniently 1 liter. So 1 liter means whatever is your molar is the moles also. So I know moles electron from IT over F. I can calculate, right? You guys can calculate IT over F, provided this is also converted to seconds. So that will give me moles electron. From that you can get moles Cu2 plus that was converted to Cu0. Basically all you have to do is divided by 2 because each moles of Cu2 plus needs twice the amount. So now I know the moles of Cu2 plus. In 1 liter will give you concentration of the Cu that was present. Extremely simple. So for this, if you calculate it, you will get something like 0.01. Okay, question number 19. So I have been given a cell. It's just a half cell. They are asking you what you can do to increase the electrode potential. So I can increase the electrode potential when I can get more of my reactant, correct? So if I get more of my reactant, obviously my electrode potential will increase. Now what you can do, if I increase Cl minus, what will happen? If I increase this, it will go backwards, because basically this is a Hg2Cl2 solution, which is sparingly soluble one, because they put this as a solid Hg2 plus 2Cl minus. So I want to decrease my Cl minus. Correct? I want to decrease my Cl minus. So by increasing this, it's a solid, it's not going to change anything. Okay, so this is not going to matter much. Similarly, this is a liquid, it is not going to matter much. Only these two are possible. By increasing Cl minus, what will happen is you are increasing the product. We saw before, increasing the product will decrease the electrode potential, so hence we want to decrease the product. So I am going to be decreasing this. Okay, so I can decrease the product. Twentieth one. How many electrons would be required to deposit so many grams of copper? Right away we know that we have done it so many times. This is going to be 0.1 mole copper. Okay, this 0.1 mole copper. To deposit this, how many electrons would be required? So we know that 0.1 mole copper needs twice the amount of electron, 0.2 mole electrons. Okay, this is moles electron. How many actual electrons? 0.2 times Avogadro number. Moles to actual is Avogadro number 0.2, which is equal to Na by 5. 0.2 is 1 by 5. So this is this. This is very straightforward. 21. What's the equivalent weight of chromium? So I know my chromium is plus 6 here, plus 3 here. So this is going to be 3 electron times 2, 6 electron process. 6 electron process, so molecular weight divided by 6. 22 is way back from our redox, but I just put it as a good example for you guys to practice. So we have this, so we know this is coupled with this is coupled with this. So we have our reduction oxidation reaction, and then quickly going through the steps, you balance all elements except oxygen and hydrogen. Then you balance your oxygen by adding the water. So there is 4 oxygens, there is only 1, so I add 3 water, that makes it 6 extra hydrogen. I balance it by 6H plus. Now 6H plus 1 minus gives you 5 plus. To balance that, I add the electrons on the right side, same way you are going to do here. PbO2 giving you Pb2 plus right here. So I will add my water to balance my oxygen, that makes it 4H plus on this side. Then you balance your electrons. Then this is a 5 electron process, 2 electron process. You multiply with this by 2, this by 5. So it is a 2:5 reaction. So 2:5. Then you can balance it. So this is a straightforward one. So they are asking what is x? X is 2, y is 5, and then your z. Right, let's see. This is supposed to be just H plus, doesn't matter, H plus sources this. So we have 4 H plus here. So when you multiply by 2, that makes it 12, this becomes 28. So maybe there is a typo somewhere there, doesn't matter, these two you got it right. Okay, going to this one, this is very straightforward. So now if you see, we have to write the cell, E cell equals E naught cell minus 0.06 by, I told you guys you have to write a balanced equation. If you balance the equation, you say that this is 3 electron process, 2 electron process. So you have to multiply this by 3, this by 2. That makes it 6 electron process, log of product, reactant. Chromium 3 plus squared divided by cobalt 2 plus cube. Now coincidentally all of them are 1. 1 means log of 1 is 0, so the whole thing is 0. E cell equals E naught cell, because if the whole thing is 0, then it is straightforward. So now you have to calculate a E naught cell by doing E naught cathode minus E naught anode. So you should get minus 0.46. Be careful, there is the same magnitude, opposite sign is given. Usually that's what they give in NEET. If you oxidation potential is given, you would actually have to convert it to reduction potential to get the correct value there. Alright, so this one, let me write this one, standard electrode potential for E0 for OCl minus going to Cl minus, OCl minus going to Cl minus. So this is 0.94, and then Cl minus goes to Cl2. Cl minus goes to, this is minus 1.36. So we want this way, positive 1.36. Now they are asking what is this. We know this to this is E01, E02. We can say E03, our class formula. So N3 E03 is N1 E01 plus N2 E02. This way, we don't have to worry about flipping all this. I converted the all values to reduction potential. Now what is N3? 2 electron process from here to here. Chlorine is plus 1 here, 0 here, minus 1 here. So 2 electron process. This is 2, E03 is 0.94. N1 is 1, N2 is 1, so these cancel out. E01 is what we want, E02 is 1.36, calculated you will get 0.52. Okay, now this is actually a good one. So this is 0.52, this is more positive than this one, right side is more positive than left, meaning this will disproportionate. We have seen this in class. Hence people add chlorine to swimming pool for disinfectation. Disinfectant is not the chlorine actually. When it disproportionates, the HOCl is the correct disinfectant, right? So 0.52 is the answer. 25 is a little tricky one, you have to read it correctly. A battery is constructed, so this is the battery. You have to balance the equation. So I have the reduction half reaction and half oxidation half reaction. This is 6 electron and this is 3 electron process. So you have to multiply by 2. Okay, so when we do E0, we don't really care about all this. All we want is when you have the final equation. When you have the final equation, this is discharging. This is the most important one. It's a battery. What they given you is a battery. So this is discharging. So this is your equation. They are asking you here battery during charging, exact opposite. During charging is electrolytic cell. So exact opposite. So you have to flip over. So now when you see it, what is the number of moles of Cr3 plus removed from the solution? Okay, what is the moles of Cr3 plus removed from the solution? Now, when you pass 1 Faraday, correct? So this is actually very tricky one. They are giving you this, they are asking you this, how much of this is removed? So as I keep charging it, this is being removed, correct? Now how much of this is removed? Now when you take a chromium 3 plus going to chromium, correct? So when I pass the current 1 Faraday, when I pass 1 Faraday, let me clean this and write it. So if you take chromium goes to the corresponding products, okay? So it goes to CrO27 plus Cr. Now we have to balance the equation obviously. Now when I pass 1 Faraday of electricity, look at chromium, this is a 3 electron process, and this chromium alone, if you see, this is a 3 electron process. And there are 2 chromiums here, so you are going to say 2 for this one and there is 1 chromium here, so 3. So when I pass the current, for each chromium going to Cr, that I need 3 Faraday, correct? 3 Faraday. If I do 1 Faraday only, then I should get 1 by 3. That should be the number of moles disappearing for this reaction. For every time this reaction happens, this reaction will also happen. If 1 chromium is formed, meaning 1 Cr3 plus is used up, correspondingly in the other cell 2 Cr3 plus should be used up. Passing 1 Faraday of electricity, you cannot make only one reaction happen. If this happens, this will also happen, correct? So if one of the reaction uses 1 by 3, this one, the other one will be 2 by 3 plus 2 by 3, the total is 3 by 3. This is a tricky one for you guys. Okay, of two things. One is we have to look into galvanic versus electrolytic cell. As a battery, it is a galvanic cell. What is being asked is an electrolytic cell. Second thing is, a same species goes to both the anode and cathode reactions. So, if anode reaction uses 1, cathode reaction uses 2, okay, let us say cathode uses 2, anode uses 1, the total still uses 3. Or the other way around, cathode uses 1, anode uses 2, the total uses still 3. You have to account for that. Question number 26. Okay, this is a very good one. You have to watch out for this reaction alone. I am going to be balancing it. OH minus gives you O2. Okay. So now when you see here, it's actually printed wrong. It should be O2 slash OH minus, because this is 0, this is minus 2 charge. So this is reduction. I'll just show you how to balance the reaction. I'm just trying to make sure you see all the pattern, but there will be typos here. Anyways, I have 2 oxygens. I have only 1 oxygen here. So what do I need to do is, correspondingly, you can put 2 OH here if you want. Then that makes it 2 hydrogens. So 2 hydrogens can be added this way, 2H plus, and then 2 minus, 2 plus, so I need electrons. So accordingly you want to add the electrons. So this is O2, this is 2O, oxygen is balanced again, hydrogen, 2 hydrogens are present, so I put a 2 hydrogen here. The total charge here is 2 minus, the total charge here is 2 plus, so there is electron count not balancing, so I put this. Now what we want to do, we want it in the basic medium. I don't want H plus, so I will add 2 OH minus on both sides. Okay, this is just like our class equation. Doing it in a basic medium, 4 OH minus gives you O2 plus 2 water plus 4 electron. That's the same that is given here in cathode. Okay, this is a oxidation reduction reaction is given, just divided by 2, because 2 electron, it is easier. So now I have my final equation. Also these two are given to you. Now if these two are given, you can calculate the delta G for the third reaction, right? We have seen this before. For this reaction we have seen. Now if I know delta G, I can do minus NFE relation from our triangle and calculate. Okay, the only difference here, see, this is simple. We have seen this in class. Delta G to E naught, we know. Also, we have seen this in Hess's law. How to calculate delta G. The only difference is how do you get the final equation from these two cells. That's why balancing. That's why we are revising redox also in next week's test. 27. What's your equivalent weight of I2? This is very simple. Sorry, this is jumbled here. I2 goes to 2I minus, so this is 0 going to 2 minus 2 electron process, so molecular weight by 2. 28. Unknown metal displaces nickel from nickel 2 plus. So nickel 2 plus goes to nickel 0 plus 2 electron. So the metal must be below nickel in our electrochemical table, right? So it is below nickel. So that is some M x plus x electron, we don't care. We also know it does not displace manganese. Doesn't displace manganese, meaning manganese has to be lower than that. Whatever, Mn2 plus if you want, manganese sulfate, right? So manganese sulfate Mn2 plus 2 electron gives you this. Remember, we want a negative slope relation. These two are negative. Okay. But manganese displaced means the metal has to be in this relation, which is not good. Electrolytic cell, this is galvanic cell. So this is the order, and these are OAs, these are RAs. So now we can arrange the order of RA, Mn greater than M greater than nickel. So you have your final answer, Charlie. Okay, again I am going into the electrochemical table in the same way. Reduction, I want it to go reduction, oxidizing agent undergoes reduction to give you reducing agent. I always write it in this way. Also, this is more positive, less positive. If you have in this, we can go through the slope. We always want these to be reacted. So, M2 plus or Mx plus can react with Mn, but the M cannot react with Mn2 plus. When this is from class, it's your job to write the table to answer this. Otherwise, this is an easy question. So, here microampere, watch out for micro. Otherwise, I is given, T is given in days, then number of Faradays involved is this. So, this is extremely simple, straightforward. Can calculate IT divided by number of Faraday, put the Faraday unit, so you will know the number of Faradays. So, you should get beta. The last one, specific conductance is given of a electrolyte is this. Specific conductance means kappa. So, kappa is given, concentration is given. What is the equivalent conductance? So, we know molar conductance is 1000 kappa by C. I gave you in class, and I also told you this is equivalent conductance is 1000 kappa by N. So, N is given, K is given, times 1000 will give you equivalent conductance. So, this is simple, it should be beta. Alright. Thank you guys. Hope this helped you guys. Practice it again and then write a really good solution set and join with your worksheet. Okay. Thank you.